One option you can use to address the Aktos case is to use this AIMMS model. AIMMS is a software development platform for optimization models, and you have this model here, or you have the graphical user interface for a model which is running behind the scenes. If you're interested in learning more about that, you can go to the tree where you have all the elements and check how it's built. Okay, for that you need to click on this model explorer. If you do that, you can go to this tree and check different sections and declarations and so on, and check how variables, constraints, and so on are built. But you don't need to do that if you don't want to. You can just use this user interface, and it's very simple. You have this solve button which will provide you with solutions when you click on it. You can choose either maximize return or minimize risk. Okay, you can change the budget. You can impose a minimum return or a maximum risk. You can pick a different number of funds. You have a minimum amount you have to invest in a fund if you invest anything, and you can select the risk threshold. And you have the values for your funds corresponding to return and risk. Okay, there you go, and the type you have. There is a column here which is empty, which is the investments that the model suggests you do according to what everything you've given it to take into account. And then you have the minimum and maximum values for the types of investment funds. Okay, and let's change some values. Let's say we have a budget of 300 and we want to invest in at least 6 funds, and the minimum per fund is 15, and this is the risk threshold we're going to let as 20. So we want to first, for example, maximize return. So we solve, and what we get, you don't see the figures right, you can just make a wider column here. So we're investing 50,000, 15,000, and so on in each of these funds. Okay, you can check that constraints are satisfied, and what we get in this text box here is that the total return is 36 and the total risk index is 4,838. Okay, now what you could do, for example, is to copy that total risk here and try to maximize return, or the other way around. You can try to copy the return and minimize risk. You can do that manually. You can go here and type, for example, let's minimize risk and impose a limit on return. You can type 36, or you can just click bounce with the return obtained. If you do that, you just get this value here copied up here. So if we solve now, okay, let's see if this total risk changes, because we want to impose that we are going to get this return, but we want to minimize risk. So we want to get, if we are in the A point I explained before, or if we are a little bit up or above our A point, if we want to minimize risk without deteriorating our total return. You can solve, and there we go. It changed a little bit. Okay, so we can do that, or we can get rid of, as long as you put 0 and 0 to mean return and max risk, you are not taking that into account. Okay, so you solve again, you get the value you obtained previously, and well, in this case I just minimize return risk, sorry. So we get a very different solutions because we have a very low value for the total return, but in exchange our risk is a quite smaller than the one we obtained before. And you can just impose bounds on return and risk and solve, and we can minimize risk and maximize return accordingly to what we bounded here. And with that, you can build the Pareto front.